D-Lab, and this is part 2 of the Fender Twin Reverb repair. So in part 1 we found the negative bias issue, and that's been taken care of. But if you remember, when I left off, there was some noise in the preamp section that I needed to address. So that's the direction we're going in this video. Now if you remember, I found that green goo up on the filter capacitor assembly. I've cleaned that off, checked the solder joints, everything's cool there. So now we're back underneath, and we're going to inspect that circuit board and see if we can find the cause for the noise. To protect the output tubes, I put some 2x4s here to space them up off of my bench, and it's also a very sturdy way to work on the amp. So the first thing I need to do is give this thing a very thorough inspection using my magnifying glass light, right? Because the first thing it could be would be bad solder connections. And these old eyelet boards, with the age and the vibration over the years, are very prone to that. First area that you really want to focus on are all the ground connections going to this brass plate underneath the controls. You're going to see a lot of these ground runners. Some of them are hidden under these wire harnesses. They go down there, as you can see, to that brass plate, and that provides the ground for the preamp board. So inspect those really careful, because a lot of these amps that come in, that's where I find the bad connections. So back to that subject of the green goo that we saw up on the filter capacitor assembly. Well, I'm finding it down here too. So if you look right here on the speaker jack, there's some more of that green solution. It's right here on the wire, and it's also sticky. See, it's coming off on my toothpick. It's down under here. See, and it's all gooey. Now if you look down here on the actual eyelet board, you're also going to see it right there. See, by that cap, there's a big like puddle of it here. So now I think I know what that stuff is, because looking around the amp, I'm spotting it in several locations. What I believe it is, if you think back to the day of when they were building old ham radio and communications gear, the quality assurance people would have to go through and check every connection in that old radio. And when they would inspect it and say, yes, that's a good connection, they would put a little dot of approval. In that case, I usually see red paint, like in the old Helicopters radios. Every terminal board will have little dots of red paint on every connection. I believe it was called Gliptil. It was like G&C Electronics, I think, still sells this stuff. Right? So it's an inspection paint, and it's not supposed to be corrosive. However, in this case, I think it is, because as I'm looking at some of these connections, like that one right there, and over here, I'm seeing corrosion. So let me cut to a different camera, and we'll zoom in on that and see what you think. So here we are, underside, taking a look at some of these contaminated connections. So right here, you can see that the goo is still liquefied right there where that resistor goes in. And I'm going to make my way down the board, and we'll take a look at some of the others. So take a look at this one. You can see that it's gotten into the strands of the wire, and there appears to be maybe rosin remnants here. So now that eyelet board is kind of pitted and discolored, so I'm sure we have a bad connection right here. Let's take a look at some others. Now over here, I'm going to try and move this thing carefully because it's a very sensitive little camera. You look right down there. If I move this wire, you can see he's actually moving in the connection. Same thing. We've got some corrosive materials here, and it appears as though we may have maybe some wax on the board. I'm seeing quite a bit of that, especially if you go up towards the front of the board. You can see the glob. So they got in here and they're having some fun with wax and green paint, right? Going over here a little further, you can see that big goob I was talking about there. So this thing is loaded with a lot of subject bad connections. Take a look under there. Kind of bad news. So what I'm going to have to do is get in here and do my best at cleaning all this stuff out of the connections, and then hopefully take some rosin afterwards and reflow the solder and see if that helps with their noise issue. So you can see I have a long, tedious task ahead of me. What I'm going to try to do initially is clean these connections with some 100% alcohol and a Q-tip, get as much of that corrosion off as I can. I'll take a little bit of solder wick, clean up the eyelet, get some of that old solder out, put some rosin in there and resolder them, and hopefully that takes care of the problem. In this case, if you really loved your Fender Twin, the best thing to do would be to pull the eyelet board and put in a new eyelet board like what Watt's tube audio sells, with all new resistors and capacitors, because this thing still has those old 10% resistors and those old ugly blue caps, right? But first off, I want to just try to give her a little bit of a cleaning and a touch up of solder connections, check the tubes, and see what goes on with that noise level. An obvious accessory that you should have in your repair shop if you're going to do this type of work is a good magnifying glass lamp that's lit like this one. This is a Luxo. So old guys like us can get in here, clean off that contamination, and inspect the connection at the same time. So here I got a bunch of the green goo off, and that solder connection underneath actually looks pretty good. So I'll just clean that one and leave it. I'm going to move on to the other ones and see what I got going there. Before we get too excited here and I do any repairs, I want to do an initial check of the noise level that I'm dealing with. So I've got the scope hooked up right now. It's across the speaker output jack, and I've got an 8 ohm dummy load, and you can see we got about 100 millivolts of noise. And that's not really bad, but the question is do we have any sensitivity? So I take a little plastic wand and I'm going to tap around here and see if we see any excitation on the scope. Alright, so I can't show you both at the same time, but I'm going to get here and do a little tappity tap, and let's watch the scope. Alright, here we go. So I'm up by the grid resistors right now going to the output tubes. You can see a little bit of distortion there, not bad. I'm back by the inverter now. You can see a lot of sensitivity, and I'm just moving parts around slightly with the probe. So I'm just doing this, alright? Just kind of going around bumping components, right? Let's go back to the scope. You can see there's something going on here. That's probably just those bad connections we were looking at. Now I'm going to go up towards the preamp section. Not too bad up there. Make sure if you do this that you use a piece of wood dowel rod or a plastic rod. Don't get in here with your screwdriver. Alright, that'd be very bad. All in all, I'm not seeing anything too alarming. So that's good. So let's go in here and start cleaning up the connections after I verify that there's no high voltage sitting there waiting for me. And of course, unplug it. So as a safety measure, I always take a resistor. This is a 40K, about a 20 watt resistor. I hook that to the high voltage to ground to bleed that power supply. Alright, and of course I do take my meter and check it. But in this case, I know there's no high voltage sitting here waiting to poke me. So pretty much what I do is I take an X-Acto knife. I'm going to knock off the hard stuff, and then take the alcohol and a Q-tip, get that stuff off the connections. So yeah, this is going to take a long time, but at the same time, since I got the old magnifying glass here, right, I'll be able to inspect it, make sure things are clean, solder up what I need to. So, you know, I always thought I probably would have been better off in my career to be a dentist because I've always liked the little intricate work. And if you think about it, a dentist is kind of like an electronics tech, right? Because you go around, you inspect for cracks, you inspect for holes, right? And then in the old days, they used to actually fill your teeth with like silver, right? So like silver solder. I could have been like Hermie. I could have been a dentist. Alright, so here's that terrible connection we saw with the wire that was actually kind of cracked all the way around the connection. So I'm going to take a little bit of flux, put it on there. Come in here with my little soldering iron. Just watch your angle so you don't burn up this wire because it will melt. I'm going to reheat it. Heat it good. You want that solder to flow into that wire and hopefully displace some of that corrosion out of the eyelet. Next, I'm going to take a Q-tip and clean up that rosin. Alright, then I'll re-inspect the connection. Alright, there's the connection now. You can see the solder is nice and flowed in there. It goes up into the wire strands. So the wire now is secure. And yeah, it does not bond well to the outside of the eyelets because they're still corroded. And that's why I say at this point it may be better just to put a whole new eyelet board in here. But I'd rather see if I can save this one. I've seen much worse than this. And while I'm at it, I'm going to change out these crummy white caps. These things are known to be troublemakers. And you remember, it was the same type of cap that we had in the bias circuit that failed. So those guys gotta go. Alright, still going through here, cleaning up connections. And I decided, hey, maybe I should take a look at the diodes here in the power supply area, since we just changed out those caps, right, in the negative bias. Because like I told you, if you lose negative bias, it's going to blow the crap out of your output tubes, right? Because they're going to run wild. Well, take a look here. See this diode? That's part of our negative bias. Goes through that resistoroid, and there's the tap off our transformer. Well, look at this lead right here on the diode. There's a crack all the way around it. Super bad news. Always inspect all connections in the negative bias circuit. So I'm going to be touching this one up. Now take a look at what's hidden under the resistor. See that connection? That's cracked too. So obviously it's a good idea if you have one of these twins, just resolder all the diode connections, alright? Because obviously vibration gets to these guys. So I've changed out numerous caps and of course repaired numerous connections. Let's take a look at the scope. Here's my noise floor. Looks like now we're just under 50 millivolts. Same deal. I'm going to get in here and tap around a little bit and let's see if the sensitivity that I had on this board is gone, or at least attenuated a bit. So here we go. Same deal, going through the board. If I really hit it hard right there, I get a little bit, but that's natural. I'm right by the inverter circuit. This is the output area where there are grid caps, and I saw some pretty big fluctuations there. Those appear to be much better, and that's probably that stupid negative bias diode. I was probably interrupting that connection a little bit. Okay. So it looks like we're in pretty good shape. Now what I want to do is inject a signal with the old audio generator, and let's take a look at the sine wave. Alright, so I'm injecting an approximate 900 hertz signal into the amp at about a 200 millivolt amplitude going into the normal jack. Let's look at the scope. I'm going to bring it up. So there's the sine wave. It doesn't look the best. You can see the bottom half has a nice sharp point, whereas this guy's all rounded. So I'm assuming that could be an issue with the inverter circuit. But what we'll do is pull our input. Let's go to the other channel. Make sure we don't have a problem with that first preamp over there. So we're going to bring up the vibrato and take a look. Ah, you see there? Mucho bettero. So the issue is in channel 1's preamp. So now we get to take a look in there. But that's a good sign. That means that the inverter stage and the output stage are working properly. It narrows my scope to this area. So the first thing I like to do when I suspect to have an issue with the channel is to verify the voltages. So if you look at your schematic, you'll see these 200K resistors. They go to the plate of the first 12AX7. So when I'm looking here, I should see that plate voltage. So that's okay. Look over here. Yep, that's good too. Now we'll look at the cathode resistors. So here's one of them. That's 1.5 volts. That's good. That indicates that the tube is actually doing some work. Look at the other side. That's like 1.9 volts. So that's kind of strange. I usually see about 1 to 1.5 volts, but let's not worry about that right now. All right, it could actually just be a bad tube. Then you've got these coupling caps, right? So these two guys would be for your tone circuit, right? So let's go here. Make sure you got 0 volts, because if you got voltage sitting there, that would indicate leakage through those caps. So we know that the cathode circuits are okay, and I put new caps in there. Okay, got those white ugly ones out of there. And it appears as though these caps are okay, and the resistoroids appear to be giving voltage to the tube. So next thing, I'll put a scope in here for the fun of it, look at the signal, and then if it's looking lousy, let's change or check that 12AX7. So I'm monitoring the output of the second stage of the 12AX7 with my oscilloscope, still injecting that tone in, bringing her up, and take a look at the sine wave. It's beautiful. Because while I was in here fooling around, I bumped that 12AX7 and boom, up she came. Obviously I had a little bit of a bad connection on the tube, and now channel 1 appears to be fine. So now let me swing the scope back to the speaker jack. Try to do all this without killing myself for you guys. Okay. Oh boy. There we go. Okay. Let's take a look at the scope now on channel 1. And there it is. She's alright. Alright, so as you can see, the repair on these old vintage amps can like go on and on forever. And at some point, you got to say to yourself, I need a break. And there it is, my break. Brought to me by the wine woman. Yeah, they can't see you, Marcia. You're waving at nothing.
Hello, I'm having a beer, thank you.
Yeah. All right. Anyway, I have a lot more work to do. This thing's going to be on the bench for quite some time because I want to just give it a long burn in and keep watching it and see what other problems are arising. But right now, it's looking pretty darn good for the Twin. Sine wave looks clean. My noise level's down. The output tubes are running fine. They're not like glowing super hot. There's no smoke coming out of it. That's always a good thing. And what do you do when they start smoking? Well, you douse it with some wine. See you again. D-Lap.